G'day there. I just wanted to do a quick one to show you that I now have variable speed on my NEMA 17. Just added that potentiometer to the analog input of the Arduino. Had a little bit of confusion at first because I was having issues with actually turning the whole thing off, but it turns out I've actually shorted out the direction pin there, which can either go high or low to control the direction. It's now shorted to ground and is permanently low. I think I did that by putting 12 volts to it by accident. I should hopefully still be able to use that Pololulu for the extruder because I think it only goes in one direction anyway. So that's currently set to full steps. If we look at the stepper table here, there's a bunch of different pin options here which can be high or low. So I've actually got some jumpers in there already. And I'll put this resistor in here. I now have 1/16 steps. These can go a lot faster. I'm not very good with the Arduino yet. I can't give it the 50 kHz signal that it could take. But it can theoretically do 50,000 steps a second, which works out to about 250 revolutions per second, or about 15,000 RPM max speed. As you can see, you can slow it right down. I could go slower than that. This is as slow as you want to send it a square wave. I could go 1 step an hour if I wanted to, or 1 step when I press a button, or 1/16 step as that is doing now. So let's have a quick look at the other step ranges while we're here. So pull that one out. And we are now doing 1/8 steps. As I said, that's nowhere near the full speed range adjustment. That's limited by my crappy programming skills. And it's very talky. That noise is actually the feedback of it on the desk. So I might look into some rubber mounts if possible for the printer to try and keep the noise down. Let's go for 1/4 steps. And we just move that over 1 spot for 1/2 steps. As you can see, when that's hooked up to, say, a threaded rod on my Z-axis, which will give me 1 millimeter of vertical movement per revolution, and I can have like 3,600 steps per millimeter of movement. You can see how it's pretty easy to get microns of accuracy with these 3D printing setups. I'm quite impressed with the accuracy that's available with all this stuff. Back to full steps there. I can't drive the computer side of it too great, but I've got a partner to help me with that stuff. I wouldn't be taking this project on alone, it's just too much for one person to do. Anyway, this is probably enough playing around with the electronics. I've just been doing this so I can get an idea of the performance of these stepper motors, the torque and response times and stuff like that, so I know how strong I need to make my frame basically, so it doesn't rattle around when they stop and start and stuff. And they're really powerful little things. This is only 12 volts too. They can go up to 35 volts, which I'm sure would be more efficient and draw a lot less amps and less total watts. It doesn't seem to be on the, if you read the RepRap forum, they're saying you can't control the steps digitally with the firmware, which I think is a bit odd. It'd be nice to be able to have it change its speed rates, step rates for different jobs. But I can sort of get it works out its distances. You tell it how many steps to a meter and it goes off that for all its printing, so I guess it'd just mean lots and lots of definitions. Anyway, I've got a pretty good idea what these motors do and a rudimentary idea on how to drive them and stuff. So I'm going to go and get on ahead with building some framework for it all. Thanks for watching.